This is 2.3a. 2.3a. We're going to talk about the product and the quotient rule. So, a product rule is when you take a derivative of a product of functions. And so the way we take a derivative of it is we take the derivative of the first times the second plus the derivative of the second times the first. All right, it's a little bit different than what you're going to look it up on Calc Chat. On Calc Chat, it's going to be backwards. And I'm going to be able to see if you just straight up copy Calc Chat or you actually did the work yourself. All right, so here's how we take it. We take the derivative of the first times the second plus the derivative of the second times the first. And that's how we take the derivative of a product rule. Now, I want to look at number 47 on your homework again yesterday. All right, so on 47, our function was y is equal to x times x squared plus 1, right? What did we have to do first yesterday? We had to distribute the x, right? Can you still do that? Yes. All right. However, I'm going to use the product rule on it. So I'm going to take the derivative of my first. Well, what's the derivative of my first here? 1. Just 1. Times the second of x squared plus 1. Plus the derivative of my second. What's the derivative of my second now? 2x. Times the first of just x. Well, now if I start combining like terms, or if I distribute, so I end up having x squared plus 1 and then plus 2x squared, right? Now when I combine like terms, what do I get? I get 3x squared plus 1. Isn't that the same thing we got yesterday? Yes. All right, what did the wise man say? Many ways to Tampa. However, sometimes we're going to have to use product rule. All right? Sometimes we're going to have to use it. Does that make sense? Yes. All right? All right, so let's do this one. So I have h of x is equal to the quantity of 3x minus 2x squared times the quantity of 5 plus 4x. So I have two products going on, or a product going on, two functions being multiplied. So how do I take a derivative of h of x? I say what? H prime of x. Well, what's the derivative of my first? What's the derivative of 3 minus 3x minus 2x squared? 3 minus 4x. And then times the second. So my second is what? 5 plus 4x. Plus the derivative of my second, which is just what? 4. Times the first, which is? There it is. All right. And so now, sometimes we actually leave it like that because we're going to use it. All right. But on this one, we're going to simplify it. So on this part, the red part, I'm going to FOIL. So what's my first? 15. What's my outer? 12x. What's my inner? Negative 20x. Those combine to negative 8x. My last is negative 16x squared. Plus, what should I probably do on this 4? Distribute it. So now I end up with 12x and then minus 8x squared. All right. And then we need to combine like terms. So I end up with h prime is equal to how many x squareds? Negative 24x squared. And then how many x's? Plus 4x. And then plus 15. All right. And so there is my derivative using the product rule. All right. This one, we got y equals 3x squared sine x. And I want to take a derivative of it. So how do I notate taking a derivative of x? Or of y, I mean, with respect to x? dy dx. So again, I have a product going on. So what's the derivative of my first? 6x. Times the second, which is just sine x. Plus the derivative of sine x is what? Cosine x. Times the first of 3x squared. Sometimes we'd be okay with that. However, you could factor something out. What could we factor out? 3x. So I'm left with 3x, and then what would we get now? 2 sine x, and then plus x cosine x. And so there is my derivative. All right, pretty good? All right, I'd like you to try the other one. All right, so on this one, the derivative of y would be dy dx. And then I have a product going on. I got 2x times cosine x. So what's the derivative of 2x? 2. So now I have 2 times what's the derivative, or then I have times the second of cosine x plus the derivative of my second. So what's the derivative of cosine x? Negative sine x. Very good. And then times the first of 2x. All right. And then this negative 2 sine x, is that a product rule? No. All right. This is just a constant multiple out front in front of 2, or in front of sine. So what's the derivative of sine? Cosine. So this is just negative 2 cosine x. Does anything lovely happen? The cosines cancel. The cosines cancel. So now I'm left with dy dx is equal to negative 2x sine x. All right. A lot of the times we bring it out front so it doesn't look like it's inside that function. All right. Pretty good? What's a derivative? All right. All right, so now we're going to talk about the quotient rule. And so when we have a quotient, we have two things on top of each other. On this case, we're going to do f of x over g of x. And this is the way to take a derivative. And if we did the product rule that way, it's going to be very similar. So the derivative would end up being the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. All right. When we take a derivative of a quotient, we do the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. All right. Pretty good? So the way that I kind of like this is because of the product rule, it's the derivative of the first times the second plus the derivative of the second times the first. I kind of think of the top being the first and the bottom being the second. All right, that's the way I kind of think about it. However, what's the difference between this product and the quotient rule? There's a what? There's a subtraction going on. All right, so we need to be aware of that. All right, here we go. So we need to find the derivative of y equals 5x minus 2 over x squared plus 1. Now, remember in our homework, like on number 45, how you had an x on the denominator? Remember that? And you just distributed dividing by x, right? And we didn't need the quotient rule then. However, can we distribute dividing by x squared plus 1 and get us anywhere? No. So that means we have to use this new rule. All right, pretty good? All right, so how do I notate taking a derivative? dy dx. So when we take a derivative, we're going to take the derivative of the top. So what's the derivative of the top? 5. Times the bottom of x squared plus 1. Minus the derivative of the bottom, which is what? 2x times the top of 5. All over the bottom squared. So now we got to do a little bit of math. All right. So we're going to distribute up top. So when we distribute up top, we end up getting dy dx is equal to 5x squared plus 5 minus 10x squared, and then plus 4x all over x squared plus 1 squared. All right. And so now we simplify the top a little bit. So dy dx equals, how many x squareds do I have? Negative 5x squared, and then plus 4x plus 5 all over the quantity of x squared plus 1 squared. Now, I would highly recommend you keep this as a quantity squared because you have no reason to FOIL it. Does that make sense? All right. So we simplify the top and we leave it just like that. Good, good? All right. Let's. All right. So sometimes it really looks like you have a quotient. It looks like you have a quotient. You got a fraction there. It's got to be a quotient rule, right? I would highly advise not doing a quotient rule unless you have to. Okay? It's a little time consuming, is it not?
Yes.
All right. So let's look at some of these. So I got y is equal to x squared plus 3x over 6. Do you have to use a quotient rule on this? No, you definitely don't. So what I would do is I would actually pull out a constant multiple. What would I pull out? A 1/6. So I would rewrite it like that, and then I would use my simple power rule. So the derivative of x squared would be 2x, and the derivative of 3x would be 3. All right? You see how easy that was without using the quotient rule? All right? Let's look at this other one. I got 5x to the 4th over 8. Well, it's a quotient. Got to use the quotient rule. Just kidding. What could you pull out? 5/8. So you could just rewrite it like that. And then you could use what rule again? The power rule. The power rule. So the 4 comes out front. Last class had trouble with this. If the 4 comes out front, what do we get? What? 5 halves. That's what I want to hear. All right, so we get 5 halves, and then we get x cubed. All right, 20 over 8 would be fine, but it's it. All right, this other one right here, this one sure looks like a quotient rule. It sure looks like it, but it's not. What could you do? You could do what? I don't want to make an exponent negative. What could we do? What?
Take out -3/7.
No. Well, eventually we could take out -3/7, but what could we do with all the x's? Take out an x over x, right? So we could get rid of one of the x's. All right? So this could kind of go like that. All right? And so then you could take out a -3/7, and then we could do a simple power rule. All right? All right, let's look at this next one. How could I rewrite this 9 over 5x squared? 9/5 x to the what? -2nd, exactly. All right, make sure you keep that guy in the basement. And then we take a simple power rule, and then there we go. All right, pretty good? All right, so sometimes let's use our constant multiple rules instead of just going into that quotient. All right, let's look at number 25 from your homework. On 25, it says, take a derivative. All right. So on this one, what do we have to do? We have to use the quotient rule. There's no other way around it. You have to use the quotient rule here. So let's do it. How do I notate taking a derivative of this one? F prime of x. So we take f prime. We're using the quotient rule. So the derivative of the top. So what is the derivative of the top? All right. And then times the bottom of x squared minus 1. And then minus the derivative of the bottom, which is 2x, times the top of 4 minus 3x minus x squared. All over x squared minus 1, quantity squared. All right. All right. So up top, we need to FOIL and distribute. So let's FOIL. So what's my first? So I get -2x cubed. And then my outer. And then my inner. minus 3x squared. Then my last plus 3. And then on my right side, I'm just going to distribute negative 2x. So when I distribute negative 2x, I'm left with negative 8x. And then all over this quantity x squared minus 1 squared. Does anything lovely happen on this one? 2x cubes cancel. I love it when things cancel. I love that. All right. So, are we left with anything else for our x squareds? How many x squareds do we have? 3x squareds. And then how many x's do we have? Negative 6x, and then plus 3 all over x squared minus 1 quantity squared. All right. All right. Everybody listen. I am good with you getting right here. Is everybody hearing me? I am good with you getting right here. You take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. You simplify it. There it is. Good? However, this one's kind of cool. This one actually keeps going. However, does everybody hear me? I am good with it right here. Good?
Yes.
All right, this one's cool though. So, guess what you could do to the top? Factor out of what? A 3. Let's factor out a 3. This one's pretty nifty. So I'm left with x squared and then what? Minus 2x and then plus 1. And then what could you do to the top? You could factor the top. What could the top factor to? 3 times what? X minus 1 quantity squared. Well, what is x squared minus 1? What is that really?
X plus 1.
That's x minus 1x plus 1. So it's really both of those quantities squared. So this is really x minus 1 squared and then x plus 1 squared. So what else happens? The x minus 1 squareds cancel. So f prime is really what? 3 over x plus 1 quantity squared. All right. It's pretty cool. However, I am good with you right there. Does everybody hear me? All right. On 74, it's very similar to what we did, I think, on 59 on our homework. We're finding the points where we have horizontal tangents. So what does it mean to find a horizontal tangent? F prime of x is equal to what? 0. The slope is equal to 0. So eventually, we're going to set f prime equal to 0. All right? Well, I have x squared over x squared plus 1. Guess what we have to do? We have to use the quotient rule. So, f prime of x is equal to what? Derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Well, we got to simplify this up a little bit. So let's distribute. So f prime is still equal to, what do we get? 2x cubed, and then plus 2x, and then minus 2x cubed. All over quantity x squared plus 1 squared. Does anything happen?
2x cubed.
Love that. Love that. So what are we left with? 2x over. Good. All right. And what am I going to do with that f prime? I'm going to set that thing equal to 0. So I'm setting that equal to 0. And so when I set that equal to 0, what x value tells me that's going to be 0? It's not a trick question. Zero. X is equal to 0. It's really 2x is equal to 0, right? The bottom isn't going to matter. All right, so 2x equals 0, x equals 0. All right. Well, it asks for a point of horizontal tangency. So what do we have to do? we have to substitute that back in. So we need to find our y value. So we set f of 0. So I substitute in 0 into my original. And guess what I get still?
0.
I get 0. So what's my ordered pair? 0, comma 0. I have a point of horizontal tangency. All right, pretty good? All right, write these out.